All right, so today we're in lesson 4, and we're continuing our talk about ratios and rates and comparing them. Now, the formula that we used is y equals kx. Who can tell me what the k value name is? What do we call the k value? It's 3 words. The middle one is a short one. Yes. Very good. Constant of proportionality. You should have that in your previous notes. Yes. You should know that k is a constant of proportionality. That is the same number throughout. It's always the same. Every number is multiplied by this k. And we'll look at more examples today. Now, the y and the x we called different names. We had one that was independent. We had one that was dependent. Okay? Now, think of Hayes, my little baby. Which one is he? Dependent or independent, Isabel? He's dependent, okay? So now, which variable, the y or the x, is the dependent variable? The y, very good. Why? Well, y depends on what these two values are. Does that make sense? So I'm introducing these terms to you early, so it kind of clicks with you. The more you see it, the easier it's going to be, okay? So y depends on what these two are. You can pick whatever value you want for x. We call that independent. You can do whatever you want. You pick 10, you pick 28, you pick 30.5, whatever. The k stays the same, but whatever those are kicks out whatever the y will be, okay? Now we're going to transition to, and they don't introduce it yet, but a new formula. I call this formula the dirt formula. That's kind of gross. Well, you'll see why it's called the dirt formula in a second. D equals R times T. You understand why I call it dirt formula? So again, you should have both these written down in your board, in your paper, on your paper, in your book. Now, this ties to something we've already done already, but they haven't assigned the name. We had 2 hand motion formula type things that we used. One that had a dollar sign divided by what you get. The other one was what? Blurt it out, nice and loud. What do we call that? Distance divided by time. What do you think this D stands for? Distance. What do you think the T stands for? Time. So this formula is called the distance formula, and we're going to use it throughout. We're going to use it later on. It's very similar to this y equals kx. The R is our rate of speed. Okay? So now, let's say you're traveling down the highway at 60 miles per hour, and you drive for 3 total hours. Well, what's my total distance I traveled? You take 60 times 3. What is that? 180. You've gone 180 miles. Okay? What we've looked at is, okay, you went 180 miles. You took 3 hours. What's your rate of speed? Well, I took distance divided by time. Right? So we've done this formula. We just didn't introduce it. But it's going to show up more and more. And I just want to throw it out today since we're kind of using it in this situation. So this situation, we've decided to walk in a long distance race. And there's 2 teams. You can join Team A or you can join Team B. Team A walks at a constant rate of 2.5 miles per hour. What do you think we call that? A constant rate of 2.5 miles per hour. We already have a name for that. Ratio? It's a ratio, but it's the blank of blank of blankety blank. Constant of proportionality. It's 2.5. Every hour they walk, they go exactly 2.5 miles, no matter what. They know their pace, they know what they need to do, and they do it. They slow down if they need to, they speed up so that they walk that exactly every hour. Now, Team B starts off really fast. They go 4 miles in the first hour, and then 2 miles every hour after that. Now, they sometimes say create a table, but they've already created it for you. On the test, you might need to create one for yourself. Notice we have distance, we have time. The distance would be like the y, right? Distance that you go depends on how long you travel. Does that make sense? Your distance depends on how long you travel. They say use 1 through 6 for your hour. So we're going to fill in right here. 1, 2, 3, 4, 5, 6. Over here, we're going to fill in 1, 2, 3, 4, 5, 6. When you get to the test, you might need to write out your own table, organize your own information. And hopefully you've seen enough examples, it's not that bad. So now if you go 1 hour on team A, how far did you go? 2.5 miles. Now, if you went for a total of 2 hours, what's your total distance? 5, right? Now, you can think of this, since this is 2.5, we can think of it like a quarter. 2 quarters is 50 cents. 3 quarters is 75 cents, but the decimal's off 1. It's 7.5, right? Or you can do 5 plus 2.5. Add those two together. If you went 4 hours, another 2.5 would put you at 10. And if you think of 4 quarters as $1, we just move the decimal point over. If you have 5 quarters, how much money did you have? 5 quarters, $1.25, but the decimal's off by 1, it'd be 12.5. Does that make sense? Or you added 2.5 to 10. And then if you went 6, let's make that a better 6, you would have gone how far? 15. Very good. Now, Team B, slightly different. They went how far the first mile? 4. And then every hour thereafter, they did how many more? 2. So 2 more than 4 would be 6. They did 1 more hour. So 2 more than 6 would be 8. 1 more hour adds 2 to my distance, 10. 5 would be 12. 6 would be 14. Okay? Now, A says for which team is distance proportional to time? Are they both? What about this? What do I do to 1 to get to 2.5? What do I do to 2 to get to 5? 2.5. What do I do to 5 to get to 12.5? 2.5. That looks good. That looks like the constant proportionality is 2.5. What about over here? What do I do to 1 to get to 4? Times 4. What do I do to 2 to get to 6? Hold up. Is it proportional? No. So which one is proportional? Which team? Team A. Team A is proportional. Why? Why is Team A proportional? Because there's a constant proportionality that is 2.5. Now, B, explain how you know distance for the other team is not proportional. Now, if we look, 1 multiplied by 4 is 4. 2 times 3 is 6. 3 times, I don't know what, is 8. 4 times 2.5 is 10. It's a different K value. Okay? So how do we know there is no consistent K value? So on the test Friday and on the review Wednesday, if it's a different K value for each pair, it's not proportional. Does that make sense?
Yeah.
Okay. Now, I want to be able to go in there and read this information. So you're going to have to flip back and forth, but I'll have the questions up here. So at which distance in the race would it be better to be on Team B? Now, we want to be in the lead, right? We want to go farther than the other team. At which point during the race, or which amounts in the race, would Team B be better than Team A? At the beginning of the race, so after the first mile, you're ahead. What about after the second mile?
You're also ahead.
Second mile, we're still ahead. The third hour, I guess we're doing hours, right? Third hour, you're still ahead, but then what happens in the fourth hour? We're tied. So at which distance, anything less than how many miles is the best? What's the cutoff for the miles? Anything less than how many miles? Where are they better? Less than 20 miles, less than 15 miles, less than 10 miles. Anything less than 10 miles is better or faster on Team B. Team B would be better to be on if the race were 10 miles or less. You understand that? Okay, they go farther. Now, if the members on each team walk for 10 hours, how far would each member walk on each team? So we got to look at both teams. We'll do Team A. We'll look at Team B. And we want to know what for each one? How many hours? 10 hours. So what's our distance after 10 hours if we're on Team A? Now, what was that special thing about Team A? They had a what? They had a constant proportionality. What do we do with the hours to get to your distance? Times by 2.5. So we take this times 2.5. That is a nice thing about proportional situations. What is 10 times 2.5? Well, 10 times 2.5, all we do is move the decimal point over. What'd you get, Jackie? 25. So they went 25 miles. Now, Team B, it's a little tougher. 10 hours. I'll go back to the table. Do we have 10 hours on the table? No. Is there a nice formula we could use to get to it? No. Not. Well, there is a formula out there, but we don't know yet. But we need to figure out, okay, if you went 7 hours, how far did you go? Well, 2 more miles would be 16. 8 hours would be 18. 9 hours would be 20. 10 hours would be 22. So there's our answer. We'd have to extend the table out, which takes a little bit of time and a little bit of effort. I might make a mistake doing that, but we did it there. And how far did they go? 22 miles. Okay? 22 miles. So which team is better after 10 miles? Team A. Now, will there always be a winning team no matter what the length of the course is or the time of the race? Is there always going to be a winner? Team A wins or Team B wins? Look at your table. Do you notice any similarities between the two tables? At what time and distance? Yeah, at 4 hours, which is 10 miles, which they asked the distance, they are tied. So is there a winner? If we said, hey, the race is going to be 4 hours long, or the race is 10 miles long.
Yeah.
They are tied. I did this. S. Tied. Okay? And notice too, before 10 miles, Team B is the best team to be on. But after 10 miles, what team do you want to be on? The Team A. Now, if the race were 12 miles long, which team would you choose to be on? Well, Team A, absolutely. Now, here's the, we can go and figure out that Team A would be for 10 miles, let's go here, or 12 miles, my bad. At 12 miles, it would take them 4.8 hours. Okay, just under 5 hours. They go 5 hours and it's 12.5 miles. We can figure out it's 4.8. Don't worry about that, I'll just tell you right there. But Team B, how long did it take them to go 12 miles? According to your table? 12 miles, 5 hours. So 5 hours. So which one would you rather be on? Well, I'd rather be on this one because I got done sooner. Okay? Now, how much sooner would you finish? Well, it'd be 0.2, right? The difference there of an hour. Now, is that 20 minutes? No, because minutes are based on 60 in an hour, and your calculator and decimals are based on 10, so we can't compare that way. But it's 0.2 of an hour. Well, over here on my wall, I have the word of on one of these posters. Can you find the word of somewhere on these posters? Right there. Of means what? Multiply. So this is what we do. We take 0.2 times, well, how many minutes are in an hour? 60. I'll take 0.2 times 60. Here's the, what's 2 times 6? 12. This decimal point, that 0 cancel out. It's 12 minutes. Okay? So you'd be done 12 minutes sooner than Team B if you're on Team A if the race were 12 miles long. Okay? Which is better than nothing. You can go start relaxing a little bit sooner. All right, next page. Bella types at a constant rate of 42 words per minute. There's an important phrase in there, 2 words, constant rate of 42 words per minute. So every minute she types, how many words does she type? 42. Now, is the number of words she can type proportional to the number of minutes? Well, let's figure that out. They say create a table, but they started it for us. Pick some minutes. And that is independent. Doesn't matter what you pick, right? The number of words you type depends on how long you have to type. That makes sense? So that's your Y, that's your X. If she typed for 1 minute, how many words can you expect her to type? 42. If she typed for 2 minutes, how many words can you expect? 84. Now, 3 gets a little tougher. 3 times 40, what's 3 times 4? 12, but there's a 0, so it's 120, 1, 2 with the 0. What is 3 times 2? 6. So 120 plus 6 is 126. Can you use a calculator on the test? Absolutely. But I'm showing you how to do some of these in your head. So later on, you can do it in your head. Now I take 6 times 42, but what's 6 times 4? 24, but there's a 0, so it's a 2, 4 with the 0, that's 240. What's 6 times 2? 6 times 2 is 12. 12 plus 240 is 252. And then 60 is really easy. I knew 6. What's the difference between 6 and 60? 1 0, so I just add a 0 here, so it's 2,520. Okay, now is this situation proportional? Yes. Our K equals what?
42.
42. Our equation would be Y equals 42x. Or we could say the number of words you can type equals 42 times the number of minutes you typed. That make sense? Okay, so that's proportional. We've seen that before. Now we have Mark. Mark just moved to a new state and he wants to go visit all the state parks. In the first month, he visited 5 state parks. So after 1 month, how many parks did he go to? 5. Okay? Now, every month thereafter, he's settled down. He doesn't have as much time to travel. He can visit 2 more each month. So after 1 more month, how many would he have gone to? 7. After 3 months, another month, 9. They want us to jump to 23. Is there a nice formula we could use to jump to 23? No, so let's do it over here. After 4, we do 2 more. After 4 months, it would be 11. After 5 months, 2 more would be 13. After 6 months, we'd be to 15. After 7 months, would be 17. After 8 months, would be 19. After 9 months, would be 21. After 10 months, it would be 23. So what do we know the months would be here? 10. Was there a nice, easy way to get there?
Yeah.
Not bad. But what if you made a mistake on that? Wouldn't it be nice to have a formula? Yeah, now, don't worry about this formula, but this is what you do. You take the number of state parks you travel to. You would subtract 5. So let's go 9. What's 21 minus 5? 21 minus 5. 16. Now, I'm going to take 16 divided by 2. What's 16 divided by 2? 8. And then what I'm going to do is add 1. What's 8 plus 1? 9 doesn't match up. Let's do it for this one. So I take the number of state parks I went to, 15. What's 15? Take away 5. 10. What's 10 divided by 2? 5. What's 5 plus 1? Checks. What about this one? What's 9? Take away 5. 4 divided by 2 is 2. 2 plus 1 is? Does it check? Yeah, but here's the deal. Is that Y equals KX? No, that's very complicated. So is this proportional? Not proportional. Normally, you're not going to know the formula, but I thought I'd throw it out there. But the key is, I took 1 times 5 to get to 5. Did I do the same thing to 2 to get to 7? No, a different K value. All right, 2 times 3.5 gives me 7. Doesn't work. All right, next page. One more example. This one shows the relationship between the lengths of a side of a square and its area. How to find the area of a square. Length times width in a square, they're both the same. So if I had a square that was 1 by 1, the area is 1 times 1, which is 1. If it was 2 by 2, I would take 2 times 2 is 4. What about a square with side length of 3? What do I do? 3 times 3, which is not 6. 9, right? Here I do 4 times 4, which is 16. 5 times 5 is 25. Don't get stuck in the 5 times 6. 5 sets of 5, which would be 25. 5 nickels. What about 8 times 8, which would be 64, and 12 times 12, which is 144. That came up in another class. I don't think I mentioned this class. Did I tell you the special name that we have for 12 dozen, which is 144? Did I tell you this? You would remember. Because it's a crazy name, and I don't know who named it, but I remember when I was a kid, we'd go buy a gross of things, and 12 dozen eggs would be called a gross. So when you buy a gross of something, that means you bought 144 of them, which is 12 dozen. So what's the special name for this? Gross, which is just kind of a cool name to have. Okay? Now, is this proportional? Did I do the same thing to every side length to get to the area? No, I did it by whatever it was. It has to be the same, times 2, times 2, times 2, times 2. These are all different numbers. So this is not proportional. That make sense? All right. We're going to skip over exit ticket for now. Let's go over to the hamburger helper. The homework helper.
Oh yeah, I had that for your helper yesterday.
Oh, my wife won't let me buy a hamburger helper. I told her about my joke. She didn't think it was that funny. All right, so for his birthday, Julian, again, this is the stuff that I want you to read over. If we have time, we'll look over it. But if we don't have time, you read over it. He gets 15 toy cars for his birthday. He was like, I want to start collecting cars. So he gets 3 more every month. Save up his allowance, he gets them. So we make a table, time and months, number of cars. The number of cars he has depends on how long he's been collecting them. Is that correct? Time is like our X. So he starts off with 15 at the beginning. Notice it's 0, right? On his birthday, 0. We start counting. It's got 15. After 1 month, 18. After 2 months, 21. What am I doing to the number of cars every month? Adding 3. Now, is that proportional? Well, what did I do to 3 to get to 24? Times 8. Is 2 times 8 21? No. Is 1 times 8 18? No. This one, the proportionality was 18. So is this a proportional relationship? The answer is no. Remember the origin? Remember the origin? What was that point called, the origin? 0, 0. It needs to start at 0, 0. If it doesn't start at 0, 0, not proportional. And then they use the example of those two ratios are not equivalent. Okay? Next page is very similar to one in the homework. They're comparing Hazel and Marcus for training for a race. The ratio is the distance they ran over the past few days. So after 2 days, they ran a total of 6 miles. After 5 days, 15, 9 days, 27. Is there a constant that I'm multiplying the days by to get to the miles? Times 3, times 3, times 3. Notice we set up the ratios down here. So what does that mean about Hazel's relationship? Proportional. If we look at Marcus, 3 times 2, 6 times not 2, 8 times not 2. Different constants, different ratios. So his is not proportional. Now, did Hazel and Marcus run a constant number of miles each day? Well, she did. 3 miles every day. Did he? No, his varied. Okay, so his is not a proportional relationship because he did different amounts every day. Hers is proportional. Your homework is on page 39. Is that correct? Page 39. 1, 2, 3. They say create a table, but they've already set it up for you. You got to fill it in. Remember, you can make up whatever number you want for the X value, which is normally your top line. Normally, I pick nice numbers, though. 1, 2, 3, 4. Maybe 1, 2, 3, 5. Maybe 1, 2, 5, 10. Whatever. You can pick whatever you want.
0, 1, 2, 3.
Or you could do 0. Yeah, you could do 0. That might show some interesting things. I would say this one, you start with 0. This one. How much money did he have at the start? 0 weeks have gone by. How much money did Caitlin have?
0.
$120. Okay. All right. So work through 1 through 3 for your homework. We'll talk about it tomorrow. Test is on Friday.